Okay, so we'll just double check that our growth string is being created. We'll make a panel and see what comes out. Yep, looks like the string has been generated successfully. We can close that off and start on our interpreter component. For that, we'll again use one of these C# plugins, and we'll just name that interpreter. Our first input will be for our growth string. And it's going to be a string. Oh, that's a bit funny. Okay, the next one is for the length of the branches. And we're also going to give ourselves a control for the rotation angle. These are going to be type double. And we can now jump into our, first we're going to make some sliders for these. So got one with 2 decimal points for a bit more control. 200. And because we're working in degrees, we'll go from 0 to 180. Plug in our growth string, and we can now jump into our script editor. So very similar to before, we've just got to identify some places for our geometry that we're creating. So we've got our information coming in, but we need a way for Rhino to store and interpret that information in the form of lines and points. So the first thing we're going to do is just create a origin point for the tree to start from. So that will just be a point 3D type. It's going to be called origin point. And when we call that, we want to create a new point in 3D. And we can use brackets after this to specify its position in 3D space. So correlating to X, Y, and Z, and we're just going to start it at 0. Next up, we need, just because the C# by default works in radians, we need something to convert that to degrees, which is the default in Rhino. So we can use this bit of code here called, just to translate that. So we're just going to multiply that out by, we're going to access the Rhino library for math, and if we type in pi, we get the pi value, and we divide that out by 180. Okay, next up we want to create sort of like a variable, a container to store, as we're creating these points in space, we need to store them in a list. So for that, we're going to create a list of 3D points. We're going to call it array, or ARR points. And when we call that, we want a new list of points. Oops. Just be careful when you, sometimes it will automatically default to something from the library. So to get around that, I just type in point3D, close it off, move the cursor away, move it back, and that should allow me to then type it properly. Great, so we've got that. We also need a variable to hold the current direction that we're moving in as we navigate through space and build up our tree. So for that, we're going to use a vector, and it's pretty similar in its composition. So vector 3D, call it move vec. And when we call that, we want to create a new vector in 3D space. And its position will be 0, 0. And if we give the z value a value of 1, that means we're pointing up, and we're going to build up from that origin point that in that direction. Oops. Great. So we also need, as we're moving through our code here, we need a place to store, the information for what to do when we hit a bracket. And sorry, not what to do, but like what position we're actually in, and what position, like what direction we're facing. So for that, we'll start with the position first, and we'll create a list, 3D points, call it point stack, and that will create a new list, 3D points, like so. And very similar for the direction, we're going to use a vector. So list vector in 3D, call it vstack, new list, vector 3D, and close it out with default brackets. Cool. So again, before we get into the code, we just need to bring in that rule from the last component where we have a character variable, and this allows us to pull up a character from our string. Great. So the next thing we're going to do is just make the kind of the structure for the for loop that will cycle through, and then we're going to create a bit of a for loop that will also create the lines from the points that we made, and then we'll come back and fill out the for loop with a bunch of if statements, instructions to kind of complete once it's cycled through. So let's start with the for loop to interpret the code. Again, using integer I, starting at 0. And we want to use the length of the growth string that we've imported. So similar to last time, we're going to use dot length to get that value. And we're moving up in increments of 1. We've got our curly brackets. And within that, we're going to use our rule char and call our growth string I using square brackets. Okay, so we're actually going to leave that for now, and we'll come back to this in a second. But we're just going to set up the loop to generate lines from points. So again, for loop, integer I equals, now this time we're going to make integer equal to 1, and I'll explain why that is in just a second. So we've got I, we're calling up our list of points, and we can use this time count to say that we want to use, count how many points are in this list, and then cycle through each one of those until it's finished. And a little bit differently, we're going to say our iteration is I plus 2. So the reason that we do this, we're not starting at 0, we're starting at 1, which will give us actually 2 points. And we're moving up in increments of 2 because as we want to create lines from points, you actually need 2 points in space to do that, right? So that's why we've kind of changed our method a little bit. Got our curly brackets, and we now just want to specify those starting points. So we've got new line from array points. Oops. Oh yeah, that's right. And then we're going to call up our I, this time using -1. So it's moving back 1 in the original group of from 0 to 1, that's 2 points, and we want to start with the first initial point and then use the next point, which will just be I. So after that, once we've called those points, we just want to add them to our line array. And we can just say .add to do that. And make a new line. And finally, once we've added that to the array, we'd also like to make that equal to our output. Similar to what we did with the growth code, we're now going to store these lines here in our output. So you'll notice that that value is A. So we'll call that and just say A equals line array. All right, so that's looking pretty good. I'll pause here and we'll come back in the next video and specify our instructions for the for loop.